So again, my name is Luke Mellor. I'm the marketing director of Pantonium. Today, I'm joined by Milos Dobrijevic, who is our project manager for Pantonium. So he's on the operations side. And then I'm also joined remotely by Jeremy Eves, who's our head of transit sales. And so these two gentlemen have years of experience to basically designing, deploying, and implementing transit projects across the world, mainly North America. So today we're just going to share our experiences, and I think it's on-demand transit has been around for decades, but in the last 10 years with the advances of technology, and also in this last year with everything that's happened, it's become more and more important because transit agencies, they're facing a crisis of ridership. They're facing a crisis of funding and of revenue. And really, with all of those coming together, transit agencies are being forced to design new services and design new approaches that they've never tried before. And we've been going on this grand experiment with on-demand transit, especially in the last 5 years. I think it's been an incredible change. But even after years of experience and years of trying things, transit agencies are still experimenting, and really they're in the dark when it comes to implementing these types of projects. And there's a lot of noise in the marketplace about how to do it. And I think we want to talk about it from a very high level, and then narrow it down to help transit agencies with their decision-making process on how to do these things. So just to get started, let's look at, this is the agenda for today. So we're going to talk about on-demand transit, define it, which I think is very important. We're going to talk about designing the service areas, which is a real stumbling point for transit agencies. We're going to look at some case studies. We're going to talk about some outcomes and metrics, and specifically the value propositions that are possible. And then we'll go through questions and have a little bit of open discussion. So to start, the goal of transit, we go over this all the time, but you want to have an equitable, sustainable, and convenient service for your entire city or service area. And you're always faced with this challenge of how do I maximize my ridership, and how do I maximize my coverage? Because those two it's difficult to balance those two things. And a lot of transit agencies, when they're faced with these low demand areas and times that don't work for fixed routes, they've turned, or they have to service populations where fixed routes don't work, or geographies where fixed routes don't work very well. They've turned to demand response or on-demand transit. And in fact, in 2018, according to APTA, demand response transit is the actual most common mode in the United States for transit. So there's more demand response operations in the United States than there are fixed route operations in the United States, which is an interesting, you never hear about it really, but it is the most popular way of delivering transit. Now, the thing is that there's many different types of demand response or on-demand transit. So this is a rather complicated chart, but it is a rather complicated subject. So I think this is the spectrum of possible demand response approaches, and there's different types, and then there's different parameters that change depending on the type, and then there's different outcomes and also different requirements for these. And today we're going to be focusing on this on-demand transit section, but we have to recognize the context that most transit is going to be fixed route. And a lot of what people think on-demand transit is really falls over here in the micro transit or in the ride hailing, especially when you ask the public what they think. So, and I think, Jeremy, you made a good point when we were talking about this. What is the difference, and more specifically, what are the applications for doing all of these, doing these kind of 4 different approaches to delivering transit?
Thanks, Luke. So, in the numerous conversations that we've had with a number of transit agencies, not every solution is going to work for everybody, right? So it's great that there are options for different transit agencies to consider when they're looking at ways to either completely change the way they do business, or the way that they maybe have to serve a certain area that either didn't have transit before, or is in a situation like you talked about where there is some form of transit there, but it's just economically it doesn't make a lot of sense. And so we hear a lot of news, like you said, about starting about 5 years ago, where technology is kind of filling in the gap where fixed route is not necessarily working well, to help connect the transit agency with their ridership a lot tighter. Uber is a great example of that, where they've really crashed the market with ride hailing services. And for some agencies, that actually does make a lot of sense. If you're doing like a first mile, last mile in a smaller population, the cost to ride ratio for that is quite high, because it really resembles a taxi service. It's convenient because technology lets people connect nicely with the service provider. The agency doesn't necessarily have to run it themselves. They can contract with any number of ride hailing solutions. But it is an expensive service, but it creates a nice personal relationship with the transit agency. So people tend to rate that service fairly high, even though the budget or the cost per ride is quite closely aligned with traditional specialized transit or paratransit, because I think you get about maybe 1.3 rides per hour. And so as you move to the right on this chart, you talk about increasing the productivity of the service. So if you're getting 1.3 for ride hailing, microtransit typically is somewhere between 2 and 5. You have smaller vehicles, you typically have smaller service areas. Your cost per ride will still be higher, but not as high as microtransit, or not as high as ride hailing. And there are applications where that makes sense. If you have kind of an isolated community that doesn't really have service today and doesn't make sense to run fixed routes, microtransit might make sense to operate there, like a more rural or low density population. But like you said, on-demand transit, that way that we define it, it actually is meant to supplement or replace fixed route transit in general. It's stop to stop, so you have the opportunity for a lot of multi-loading, but you still use the same technology that you would see in the microtransit or ride hailing side, where riders can still schedule their own trips, but it follows a model that's more aligned with typical public transit, which is why we've been focusing on that. Call it macro transit, because the service goals are aligned with the transit agencies, and you can use the existing vehicles that you have, whether it's a cutaway or a 40-foot bus, and you can get the productivity that you would typically like to see with standard public transit or conventional transit, where you're getting into the cost per trip of about $3 to $4, depending on how popular their service is. And so when we have these conversations with folks, it's important that we try and flush out what are the goals, right? What do you have available to you? Do you want to take a long-term approach to this, or do you want to try and get something on the ground in the near term? And all of these things kind of push together, and it very clearly kind of defines the type of service that should be launched. And so for folks on the phone, when you're thinking about ways to either offer new service or supplement service or replace service, these goals need to be flushed out, and then you can start. This chart that Luke created is very comprehensive. It actually is almost like a how-to guide, because it will give you a good sense of what you're looking at in terms of what implementation will be the most successful for the application.
And you brought up a good term there, macro transit. So I've actually identified. So what we've seen in the marketplace a lot is people assume micro transit is on-demand transit, and they merge those two terms together, even though there's so many factors that differentiate them. So we did come up with this term macro transit to help differentiate from an on-demand transit service from a ride hailing or a ride sharing type solution. But of course, with these new terms, you always want to define them properly. So Milos, what would you say is kind of the most succinct definition of this macro transit term?
Yeah, so I think Jeremy actually drove it home with a lot of the points that he made. And with these metrics you see towards the bottom, that's also going to make that understanding clear. But for a definition that you can sort of take home, in one sentence, it would be that macro transit is just at that larger scale, where micro transit tends to be a bit smaller operations, tends to be curb to curb with smaller vehicles. But if you're looking to take a definition home, what I'd say is that macro transit is an on-demand transit or demand responsive transit style that's at the size and at the scale of public mass transit. And that's really only made possible recently with the developments in fleet optimization technology.
Yeah. And I think just to drive home, I think the core difference in macro transit is the productivity. And if you were to look at everything that's going on this chart, the most critical factor is that it's not curb to curb, it's stop to stop. And it's really focusing on having a frequent amount of sharing. So you really want to share those vehicles as much as possible and have as many people on the bus as possible, just like a fixed route transit. You want to, fixed route is all about stuffing as many people onto a bus at the same time as possible, within reason. It's the same thing with macro transit. And truly trying to get as close to the fixed route transit experience as possible. Now, once you've decided on, okay, we want to do an on-demand transit service like this, there are still different ways that you can do that. And as Jeremy alluded to, it depends on what your goal is and what you're working with currently. So, and really we've identified 3 frameworks for deploying an on-demand transit solution that pretty much covers every kind of approach that you could take. So we'll look at the first 2. So these are 2 different types of on-demand transit systems that you could deploy. And there's some critical differences in them. So Milos, why don't you just explain to us what's a complementary system versus a supplementary system, and then what are the differences between these 2 kind of approaches? And then we'll get to the third one, which is a little more complicated.
Yeah, so later on, we're going to talk about where on-demand transit really shines and where fixed route transit is still the best. And we're also going to look at some case studies too. But first, it's good to kind of nail down just the actual forms it can take. So if we actually start with the right-hand side, which is kind of the most easiest to understand, we call this a supplementary system. And really, it's the key driver here is just introducing service to a new place that's unserved before. So that could be in the context of a new physical area. So perhaps you're serving a town already, but you've introduced a new rural area or new ward that requires service. That could be an example of supplementary service where you're now introducing transit service. You've chosen to go on demand, and it's the first time that this area has service. Another example, though, could be an unserviced time. So maybe you have a city or a town that already has a functioning daytime service, but night is now unserved, and by popular demand, it's being asked for. If you want to get your feet under you and start with a service, you could start with on-demand, which is what we recommend because you can gain a lot of understanding about the ridership patterns in this new sort of unserved territory. But in one sentence, I would say that the supplementary concept is just bringing on-demand transit into a new unserved place. In contrast to that, complementary is really where we get into the realm of replacing one or more existing routes. So generally speaking, it's where we're taking over lower performing routes and usually keeping some of the higher performing routes as well. So one thing that's kind of useful to point out with this graphic is that in this case, the on-demand area is sort of adjacent to the fixed routes. You can see it's replaced some, but it's all on the left-hand side. It need not be that case. It could be sort of overlapped as well. But the concept stays the same, which is that we're keeping those high functioning, well and efficient fixed routes and basically allowing on-demand to scoop up the rest.
Yeah, and just to explain this image a little bit, we spend our whole day staring at maps, so it might be clear to us, but basically we have a small town with 3 fixed routes, and they in the supplementary version, and this is typical in most towns, you have a rural area that maybe there is no service or there's very limited service. So we're just going to cover all that with on-demand, maybe make a bunch of virtual stops, and then have transfer points to connect to the rest of the fixed route system. And in the complementary system, you want to use on-demand to take a bite out of that initial network and then complement the rest of the network with an on-demand service. But let's move on to the last type of service, and that's what we call a primary service area. And this is where all the bus stops and pretty much every spot in the city that you're responsible for is made available for on-demand. So Milos, can you tell us what you think of the primary service area? What are the advantages of this, and where would you deploy a primary service? Give us a use case of some kind.
Yeah, so you absolutely nailed it. The definition of a primary service area is really that ODT, or on-demand transit, is the only show in town. This is really useful at night when the cost of operating a fixed route stays the same, but the benefit decreases. So anytime where system-wide really the ridership and the efficiency is going down. So we see this a lot at nighttime service. We see this a lot at overnight or even on weekends when the pattern is a little bit less predictable. And that kind of cross-pattern style of transit can really throw fixed routes a challenge where on-demand can adapt in real time. So we generally see it at nighttime, overnight, or weekends. And the primary benefit of a primary service area is really that you're not going to get any more insight than this. When you have a primary service area and you open up the entire area, you're letting the riders tell you where they want to go. And the amount of insight that you glean from the data that flows to the system when you have a primary service area is tremendous for making future planning choices.
Yeah, and just to drive home that last point, Jeremy, I think you have a very good analogy, that mudding analogy. I think that's very applicable to the primary service area. I love that analogy. If you can recall that one.
Oh, it's the mud method of transit, right? When they build new neighborhoods in different municipalities, I learned from consultant and construction friends that they put in all the services, the roads, the sewers, the electricity, and all of that, but they don't put in the sidewalks. They wait to see how that community carves out like a trail in the grass around the neighborhood to see what the natural pattern is, almost like a deer, making trails in the woods. And then they go back a little later, and then they see these pathways, and that's where they put in the sidewalks. So it instead of putting sidewalks everywhere that are going to be unused, they then just spend the money on the asset for those areas that people actually travel. On-demand transit is very much like the mud method of sidewalks. It's the mud method of transit because instead of going out and paying consultants to do demographic research and make assumptions and try and figure out how riders are going to use the service, you actually let the riders tell you how they're going to use the service and you don't have to put in all of your physical assets in place. You can actually put in a series of virtual stops in an area that doesn't already have stops, and you can see which ones are used most frequently. And actually, I think we're going to touch on it a little bit later, but in an actual on-demand implementation that we're in a city that actually deployed it across their entire service area, only about 10% of stops are used most frequently, and actually a high percentage, like in the 80% range of stops, are actually not even used at all. And so it's a very unique and data-driven approach for agencies to deploy new service without having to it takes the guesswork out of it, right? Because you're actually responding to the demand of your ridership.
Okay, and so we've talked about the three kind of high-level ways that you can design a service area, and now let's drill down. And when you're actually looking at a map of a city and just trying to decide, okay, what's in and what's out, how am I going to draw the service area actually? And to do so, we have a few case studies. I think we're going to start with one that wasn't done by Pantonium, but I think it's a representation of what we've seen a lot in the marketplace in terms of other microtransit pilots and the types of service areas that they've designed. So this right here is or was the service area of what was called the trip to strip done by the RTC. So that's a regional transit agency for the Las Vegas region. I know this service existed for about 6 months last year, and it was a micro transit pilot between RTC and Keolis, and it was your typical micro transit. You had small vans, curb to curb. There was a few interesting factors. So it was pay by distance instead of just a flat fare, and there was it was Las Vegas, so you could bring open containers of alcohol on it too, which is an interesting. I've never seen that before, and it cost about $3 million to operate, but it was a 24-hour service as well. I guess Sin City never sleeps, so and that's also an interesting component. But looking at the service area, it's very telling. It's a very typical microtransit pilot where they're trying to focus on an area, and it makes sense at a high level. When you think of Las Vegas, you think of the Las Vegas Strip. That's where all the action is. That's where all the demand is probably concentrated. So if I'm a designer, I just want to focus on where I think the most ridership is going to be, and I'm going to narrow that down. But Milos, why don't you just talk us through, first of all, that service area design, what your impressions of it is, and then also some of the service parameters that they chose for this pilot.
Yeah, I think just looking at this map, even there are a couple of learning opportunities here. And to Luke's point, I think that no agency is going out trying to set up a bad service. I think I'm seeing some really good intentions here, especially to Luke's point about trying to anticipate the ridership and focusing the resources on that. But generally speaking, especially in the macro transit context, the first kind of critical mistake here was not opening up that service area. So we want to give as many options to our riders as possible and give them the tools that tell us where they want to go. And so generally speaking, what we're seeing with this shape is that for those riders who are going up and down the strip, I would actually bet that the service was probably somewhat convenient for them. But for the rest of riders, we've just turned them away. So we've created an area that's actually not relevant to a lot of our ridership. And I would say that was probably the first critical mistake. The second one, which you can't see on this graphic, was that this is a curb-to-curb service. So we're not here to bash curb-to-curb. In fact, in our capability, we can do curb-to-curb as well. However, we definitely encourage stop-to-stop, and it's what we're best at. The reason why curb-to-curb can sometimes be difficult, or why we don't recommend it unless you're absolutely going for that kind of service and you understand the consequences, is actually a few reasons in itself. So the first is efficiency. When it comes to curb service, stop-to-stop will always beat it. And that's just because we're spending a lot of time on residential streets, and there's absolutely almost never multi-loading when you're picking up an individual rider, because you're often picking them up at their house or at their place of residence, as opposed to a stop-based service where a number of riders are waiting at a stop and you can kind of scoop them all at once. Of course, the other problem with curb-to-curb is simply the amount of edge cases that end up bubbling up. So when you design a transit stop from an urban planning perspective, there's already bus bays, it's approved, we know we're going to be able to stop there safely and conveniently. Residences take all kinds of shapes and forms. So we're talking about front doors that are actually in an alleyway, cul-de-sacs, residential apartment buildings, where the expectation of the rider and the actual service you're able to provide varies depending on where you're trying to go. And a lot of time and resources is actually eaten up on that very last bit of the leg. And of course, anonymity. We always say keep public transit public, and part of that is preserving anonymity. We don't need to know anything about a rider in order to give them excellent service. But the moment you pull up to a rider's home, everybody else on the vehicle now knows where that rider lives. So it might be a tertiary reason, but it's something we value anyways. But I'll throw in another reason as well. I think the final reason, which you also can't see from this graphic, and that is that they did not allow walk-on trips. So walk-on, another term you could use is ad hoc, but this is cases where a rider does not already have a trip requested. They just wander onto the vehicle and say, hey, take me here. And that's actually not something they allowed in this service, which is interesting because I think like the Las Vegas Strip of all places is really the place where people are not planning ahead of time. But in this case, they decided to turn away walk-ons and we're really ignoring a big chunk of the population. And there's kind of two sub reasons there. First, keeping public transit public means keeping it equitable. And what that means is that we need to be able to include the entire community, whether or not they have Wi-Fi or even devices. And second of all, even with the best marketing campaigns, you're not always going to be able to reach 100% of the population. It's just not possible. And so for those riders who didn't know about the service, they would walk up to an on-demand vehicle and probably be turned away. And you'll see later that actually a big chunk of our ridership does come from walk-on service.
Yeah, so I think they took away from this pilot that people did choose to use micro transit service, but unfortunately it wasn't sustainable. And this was pre-COVID, so even going forward with constrained budgets, sustainability in terms of economic sustainability of a service is the most critical thing. And you can't approach designing a service assuming you're going to have millions and millions of dollars of budget to sustain it forever, because that just is not the case. So unfortunately, this was killed off just at the end of last year. So now let's go into a few examples of case studies where we've been able to design an on-demand transit service that is sustainable. And the first use case, and just one more thing. We have this little tip for designing a specific service area, and we call it the Walmart principle. And it's just what we've seen from almost every single deployment of on-demand transit is that the most popular stop is not even the transit hub of the city. It's actually the Walmart. Or any kind of equivalent of a shopping center, a major shopping center. So in this case, this is from Belleville. So Belleville had a night bus service that covered the entire city using Pantonium. And after months of data collecting, we found that Walmart not only was the most popular stop in the city, but it is also the hub from which most of the travel came and went from. And you can see that here, the kind of waterfall of trips, of origins and destinations flowing to and from the Walmart. Everything else pales in comparison. And this has been repeated multiple times. So as a quick rule of thumb, when you're designing a service area, just make sure there's a Walmart in it or some kind of equivalent. And if there is something, or if there's multiple versions of this in your service area, there's a good chance that it's going to be a healthy service area and work very well. And that may be another reason why a lot of microtransits fail, because they don't include these areas in their service. They don't include these types of destinations in their service area. As a rule. So now let's get into a couple case studies. The first one that we're going to talk about is St. Albert Transit. And now St. Albert is a town of about 60,000 people. It's a suburban community outside of Edmonton in Alberta. And it's a small town in that sense, but they do have a very robust transit network. So we're just going to look at, this is a map of their daytime fixed route service. So they have multiple routes. They have this main arterial road that goes through the whole city, and it kind of divides the city into two parts. And that'll be important later. So their daytime service worked fine. They're happy with it. However, they wanted to provide a nighttime service, especially for people coming back. There's a commuter bus that took people from downtown Edmonton to St. Albert, and that deposited people in the center of the city. But then they wanted to be able to distribute those people, get those people home, basically. The problem is they only had 2 buses to cover this entire network with a service at nighttime. And just looking at, you have this many bus routes to serve, there's no way that you could do this with 2 fixed route buses, or 2 buses doing fixed routes. It's just impossible. So they did do a dial-a-ride service, and basically the way that worked was riders would call the buses directly and ask for a pickup or drop-off. However, that's not very scalable when you're having the bus drivers do dispatch. So they turned to a technology company, us. So the first thing you do is you look at they chose a primary service area. So they wanted all the stops available. So this is a map of all the bus stops in the city. And that's really the first thing we need. And I know, Milos, we talked about this a little bit, but you identify when you're designing a service, especially when you're thinking about this in the early stages and you want to determine what you should do, what's the kind of data that you require? So if you're a transit agency, what data would you need to give to Pantonium to even start designing these types of services?
Sure. So, I mean, we're eager to hear from agencies no matter what they have. And oftentimes enough, they really have a strong grip on where they're struggling. So, not much is required, but if you wanted a reasonable starting point, we can kind of nail it down to three things. And first off, it's that service map. A lot of agencies actually have the literal shape files that we can put into a geographic information system and really get into it for analysis. That's tremendously helpful for us, but even just a simple map will do. But second to that, and perhaps more importantly, is the ridership, but the ridership per route, per hour. That's really going to help us understand where people want to go. As often enough, agencies don't actually know where riders are alighting, but even just knowing the boarding and knowing on which routes and at what times they're getting on is incredibly helpful for us. Of course, if you know how many vehicles are on each route, that is something we're using to consider when we're doing the vehicle cost calculation. And then finally, just getting an understanding of the actual capacity of the vehicles themselves. So a literal understanding of the amount of seats, the wheelchair seats, and any other special attributes those vehicles might have. So if you're considering paratransit, do they have lifts? Do they have tie downs? These are the kind of bits of information we're using to at least get started.
Yeah. So in the St. Albert case, they provided us the ridership data for their current service and also some other fixed routes. They also provided us what we used for this map, which is the location of all the bus stops. And really those are all you need if you want to get started planning this stuff out. It's not complicated or onerous. You really just need a bit of data about the riders. and we'll get into why having the ridership data is very important when we start talking about metrics, objectives, and value propositions. But in the St. Albert case, primary service area, they wanted to do the whole city. We thought, great, put 2 vehicles on it. And then they've been running for a few months now this year. And this is the kind of data that we've generated from just running for a few months. And this is a heat map of vehicle locations, so tracking via GPS. This is basically where the buses at nighttime went. And really the first thing you see is this main corridor is the hotspot. But the rest of the city has a pretty even level of coverage. So you can, if you recall that fixed route map, you saw those fixed routes kind of going out everywhere. Very easy to cover all that area if you have a dozen buses, but when you only have 2 buses, it would be pretty difficult to have a reasonable fixed route cover all of that. So this is a case, a perfect example of first of all, Jeremy's mudding method, because looking at this, I know, okay, a fixed route going up and down this street would be perfect, and then maybe 1 or 2 other on-demand buses feeding in as a supplementary. So this is an example of taking we will see what St. Albert decides to do, but using an on-demand service, primary service as a starting point, you can start gathering this data and then making insight, using that data to make inferences on what is the next step for the service. So we could see this service transitioning from a primary service model to a complementary service model, would you say?
Yeah, absolutely.
Yeah. Okay.
Hey, Luke, I actually don't know the answer to this, so I'm going to ask you live here. But what did St. Albert say when you said that we can use the entire city limits as a service area, right? Because that's not what Pantonium was a little late to the game with the technology approach for on-demand transit, and so a lot of the existing technology providers, and it's based on a technology limitation of the performance of algorithms, but a lot of them have required that cities split their boundaries up into service areas, whether it's 3 square miles or 5 square miles and that type of thing. What did St. Albert say when you thought when you propose the entire city.
Yeah. So St. Albert was an interesting case, and I think this is when you're thinking about technology capabilities and what's possible. So St. Albert was using a manual process, and because of that manual process, basically they were asking the drivers to be dispatchers. Because of that manual process, they had to split the city into two service areas. So they used this dial-a-bus service, and they basically said one bus is on the east side of the city and one bus will cover the west side of the city. And they did that because of the limitations of humans in building plans. Because if you have two vehicles covering the entire city, that's a much more complicated plan to create basically what stops I'm going to go to based on my demands. Very complicated, and it was much more complicated than I'm just one bus trying to decide on this limited set of stops. And I think, to Jeremy's question, I think one of the reasons why we've seen so many micro transit pilots be developed with very small service areas or lots of little service areas all in one city is because of the technological limitations. And a lot of these agencies are doing it manually, or they're using software that was designed 30 years ago that doesn't have the capability to build routes in real time for large service areas. Because these problems get more and more complicated, the more vehicles you add, the more stops you add, and the more riders you add. And I think those limitations, they don't exist as much anymore, but the mindset of those limitations is what causes some cities to be very skeptical and worried about doing a primary service and so they don't want to cover the entire city, when really this is how you get it's much more simple just to cover everything and see what works and what doesn't, rather than splitting up a city into many parts, because it's not convenient for riders and it's not efficient for planning and routing. And so this is a St. Albert example, and we've got another use case. So this is Ozark Regional Transit down in Arkansas. So Ozark is an interesting agency because they cover multiple cities in their purview, essentially. So Jeremy, can you give us a little bit of background on why Ozark Regional Transit decided to use Pantonium and on-demand transit?
Yeah, as typical in a lot of different regions, public transit in Arkansas is not well funded, and the town that we ended up deploying in, Rogers, Arkansas, had a wholesale change in council and leadership, and the new council really wanted to make transit a priority, but they didn't have unlimited budget to buy a bunch of new buses and build the fanciest service possible. So the executive director of ORT was exploring options, and he and I struck up a conversation about what was possible using just two cutaway vehicles. And given their goals and what they were trying to achieve, he was very confident in proposing our solution, the way that we kind of developed it together with his team and with Milos, actually. They proposed it to council and it was approved, and it was deployed in January of this year. And I guess we're going to get into kind of the success that's been seen running a full day service of on demand, which was interesting to see, because we had been typically only deploying evening service or weekend service. So I guess we can dig into that right now.
So Milos, so you were involved in the design of this service. So can you walk me through kind of a step-by-step and specific? I think we're going to focus specifically on how we consider expanding coverage for a service. So why don't you just walk us through what we're seeing here and what we did to deploy this?
Yeah, so this is the city of Rogers, and we can see a single fixed route that's kind of operating in a figure eight sort of fashion in the core. But we see huge gaps in coverage, especially on the west and south sides. And so the first thing we thought about is let's get a radius on these stops and develop an understanding of what our actual coverage is and where those gaps are. So we use a very common rule that we often just refer to as the golden rule. For our Canadian friends, that's 400 meters or 1,300 feet. from any direction from any stop in terms of what your average rider is comfortable or willing to walk to a transit service. And now that we have these radii drawn, we can kind of look for gaps in coverage and start recommending more stops. And I'll explain now as well why we would even do that, or why we would even bother adding new stops. As Luke mentioned earlier, the mindset can kind of lag behind the technology, and that's a bit normal. So going, considering this from a fixed route kind of state of mind, adding a stop can be a really difficult challenge. So once you kind of pick the stop, you need to now choose which route, which fixed route is actually visiting that stop. Once you've done that, you've just now made your fixed route longer, which makes your headways longer, which might now lead to a mismatch between our riders' expectations and what you're actually able to provide. But not only that, now you're retraining your drivers, you're redoing your signage, your schedules. There's a lot of work into that goes into picking a new stop. And if it's a new stop, it probably wasn't very popular in the first place. So a real small win for a lot of work. And when we turn this into a satellite view, a lot of the yellow recommendations, which are actually our stop recommendations, were in fairly rural areas, or let's just say less dense areas. So it sort of makes sense why Ozark wasn't considering these before. But in on-demand, it's the exact reverse. We want to really liberally add stops to the service area as much as we can. So earlier we talked about those on-demand transit killers, going curb to curb when you really don't mean to do that. Constraining your service areas and not allowing walk-ups. This is an on-demand winner. Adding stops as liberally as possible is a good play. And the reason why is because even if it's really, really unpopular, what happens in on-demand transit is you just add a stop to the network. It's really that simple. It could be actually weeks before a rider ends up going to that stop. But the beauty of it is that you will not incur the cost of going to that stop until you want to, which is when there is demand for that stop. And so it's a real small cost, and the win is quite substantial because to some rider that stop is relevant, and that's how you actually pull out the latent demand through convenience.
Yeah, and just to follow up on what's been happening in Rogers. So they started earlier this year with only one vehicle running running on demand, and they had one vehicle running on that fixed route. So again, that's a supplementary or complementary service. But recently, I think it might be because of changes due to COVID, and also because of the performance and the popularity of the on-demand service. But Rogers decided to scrap the fixed route and just to take both vehicles and run them on demand across this entire service area. So this is an example. It's a kind of a reversal of the typical approach, which is roll out the on-demand service and then learn from it and then replace parts of it with a fixed route. In this case, we kind of went in reverse. Again, go ahead, Jeremy.
It's also important that they had very strong support from council with a data-driven approach, right? So they're able to go back and our support team provides regular reporting on things that maybe you have to do a bit of a big data analysis on this, and our team provides that report to give the transit agency fact-based information about what riders are saying, right? And that happens with every one of our deployments. Every single one of our deployments has used the data that was generated by this service to enact another change, add another vehicle, extend the hours, provide more service opportunities, right? And either that is in maybe an acceleration of wait times, during certain times of the evening or the day, or just by stranded riders, because that does happen periodically. If the demand exceeds the capabilities of the network, then wait times will go up and riders will self-select and not take part in the service. So there's that data. At least that data is available. Before with a fixed route system, the only complaints that you got were either on Twitter or just grumbling amongst the passengers themselves. How else can you engage? Also, with a tech-based solution, you have a lot of rider information, not a lot, but you have rider information. So you can send out ridership surveys. You can engage with them through mass messaging that goes out through the apps. you can actually turn stops off and on depending on certain types of events that are going on. And so it really creates a much more, the utility industry actually has been doing this for the last 10 years, and they're creating a relationship with their customer base that wasn't available to them before. Now transit has that capability with technology of creating a bidirectional relationship where you're actually responding to, you actually have the capability to respond quickly to ridership changes in ridership behavior. And so the other thing that Ozark did, and we're talking to them right now, it hasn't fully gone live yet, but it's commingling of services, which, we haven't really got into too much because, we're trying to focus on just, when you're starting to plan services, but they're now thinking about how to integrate paratransit with their conventional transit, because they have the on-demand service. A rider is a rider and all the vehicles are accessible. So why can't they use the same service to support those that with the disabilities? And it's entirely possible depending on the types of vehicles that you provide. So every single one of our deployments yields new insights, and we keep bringing these insights to future partnerships.
Okay, and to follow up with that, it's good that you're talking about the wait times versus the number of vehicles, because I think we're going to get into the objectives, and really we're going to look at this from basically the most obvious objectives, and then kind of narrow it or broaden it out to the less obvious objectives, because really it's up to the agency to determine what matters to them, and we can only help show these are the big wins, these are some small wins that you could also have. So starting from the top, this is a typical kind of value proposition where you, and this is where knowing the ridership data and knowing the kind of fleet composition and the costs associated with that is so important to do these. Because going back to the Las Vegas example, I don't think they ever looked at it from a value proposition standpoint, or maybe they just had a different idea. But really, the best and most simple value proposition is, how can this save you more money than it costs? So just to start, the low-hanging fruit for on-demand transit, in our opinion, is always night sign service. So Jeremy, can you walk us through? So this is a kind of a standard. It's not real numbers, but I think it's pretty relatable for most transit agencies. This is kind of or the cost of providing a nighttime service.
Yeah, it's really just an illustrative example of a mid-sized city, right, that has the challenges of any typical mid-sized city, right? You've got 75,000 people. You probably have some form of higher education, whether it be a college or a university. So you have an influx of students during certain times of the year. And you need to provide some form of transit in the evenings to allow for mobility through, whether it's educational mobility, economic mobility, employment, or entertainment. And so a well-funded transit system typically will offer some form of night service, whether it starts at 7 o'clock or 8 o'clock or 9 o'clock. These tenants typically apply. We've used a common number of about $100 per vehicle hour for operating costs. No one really bats an eye when we talk about that. It's either somewhere in that realm, whether it's $80 or $120. It kind of just depends on the territory. You definitely want it, Monday through Friday, and we've got this example illustrates 3 hours a day. So for a city of 75,000, you would typically see about 7 or 8 buses running night service for 3 hours a day at about $100 an hour. What we're seeing based on some of the data is that you're getting around 10 riders per service hour per vehicle, and that would equate to about 240 riders a day, which is the equivalent of $10 a trip. Now, for a well-functioning system, we think about $3 a trip is what the goal should be. So if you add up the cost of running these 8 buses, it's about $624,000 per year. And per vehicle, it's about $78,000. So when you start breaking it down like that, you get a fairly good sense of the numbers. And when we talk about microtransit, you're not going to get good results with microtransit. You're going to get 3 to 5 riders, per vehicle hour, right? And so this type of solution, we have the capability of actually replacing a fixed route service, and we've done it several times now, you use the same vehicles, you use the same or fewer vehicles. You could expect that the ridership numbers either stay the same or grow. And in a lot of our cases, we've seen pretty substantial growth in ridership when you transition to an on-demand service. But you can do it with even fewer vehicles, because a well done platform with a powerful algorithm can handle up to about 30 riders per vehicle service hour, even in a situation where you have a high demand and limited vehicle availability. And so I guess we can talk a little bit about what the impact of that is if you start talking about how you can reduce the number of vehicles. So
yeah. So I think to highlight, the core is the difference between what your current rides per service hour is and what you could potentially have if you switch to on demand. So if your service is only running 5 per hour or 10 per hour, there's a potential to double or triple that number. And then that's where you reap the economic benefits. So and we'll just blast through this really quick, but assume you start with those 8 vehicles. That's kind of the existing service. If you could just knock 2 or 3 of those vehicles off the service and boost the ridership per service hour while still maintaining the wait times that you want. And again, you can do this on a day by day or hour by hour basis to make sure that the service level doesn't fall below a certain threshold. But you can save, hundreds of thousands of dollars, even this is a very small scale example, but the system pays for itself just by more effectively carrying people per hour. And just Jeremy, I know we could talk about this forever, and I know you've talked about this forever, but just in the interest of time, we're going to blow through this slide. So if you can't cut vehicles, you could always find secondary objectives like increasing ridership. Maybe you can collect more revenue, or you can also just increase coverage with this type of service and save yourself. Let's say council is forcing you to cover an area that's never been covered before, and you don't want to break the bank to do it. You can deploy an on-demand transit. So maybe that's your objective. And there's a whole bunch of objectives that this could meet. It's not just about saving money, saving on the bottom line. And this isn't even exhaustive either. You can keep going, but things just like saving bus maintenance. You don't have to run a bus along a fixed route empty anymore. You just park it in the main station and wait for people to come and ask. And then of course the data and consultants, that's a big value. Again, providing first last mile, if you have another train station, just tons of different ways that this can be a benefit. And then finally, here's just some high level questions that you need to ask yourself. Who's going to be using this? Because if your population is a bunch of students versus a bunch of elderly people, you're really going to have to think about the service parameters and what is available. Like, what fleet do you have on hand? Do you want to spend millions of dollars contracting this out, or do you have existing vehicles that are underutilized? And then where is the best service area? I think we've talked a lot about that. Is there a Walmart in there? That's pretty much all you need to know. And then when, is your system performing well at certain times but not at other times? And then ultimately, again, why do you want to do this? You have to go through that grab bag of objectives and pick the ones that mean the most to you, and then make your decision based on that. And then it just becomes a how question. And how do you want to do this? And what is the best way to match those needs and objectives? Is it a ride hailing? Is it a micro transit? Or is it a macro transit solution? And really, once you have the data on hand and think about it, I think it's pretty clear where each one of these falls in the service area that you're designing. And now we'll hopefully have some time for questions. I'll just open up the Q&A. And it looks like they've all been already answered. So excellent job, Dawn. And we'll actually be able to finish on time, which is spectacular. But I think I have one more question for both of you, and it's, how do you get that productivity? Because I think the ultimate goal of a macro transit is to really drive that productivity, because that's the thing that drives demand. And well, we do have a question from Andrew Byrne, the Uberization of transport. Oh yeah, he agrees. Thank you, Andrew. So my question for you guys is what is the best way to get that productivity as high as possible in order to really get that bottom line improvement that makes macro transit really a special thing in the spectrum of on-demand transit services. So anybody want to, Milos, do you have?
Sure. Yeah, I think the first thing to say is that is to not constrain it at the start. Like we said earlier, riders already know where they want to go, so transit agencies just need to listen. Give them the tools to be able to go from any stop to any stop transfer free, and start reining it in and constricting things later as the information flows through. There's all kinds of information that you get from an on-demand service that I see a lot of agencies really scrambling to get. The kind of information that we just generate naturally. Things like where they're headed, how far in advance they're requesting their trips, how they're requesting their trips, wait times, on-time performance, ride times. There's a lot of information that you can use to rebalance your service as you continue on. So opening it up and reining it in later is gonna give you that advantage.
Yeah, I 100% agree, and also because of how transit has been operating and planned historically, there is a pretty strong, I guess planners and agencies have typically had to go through a lot of planning time, right? A lot of time to evaluate and test or debate, bring it to council, bring it to the riders, have town halls, public consultations. I'm now of the opinion, after seeing several deployments, is just give it a shot. People aren't going to fault you for trying something new, right? And there might be some hesitation from council members, but the good news is that no one on this call is the first one anymore, right? There are a number of deployments. We've got a number of other technology providers have deployments out there. So it's not really a proof of concept. Now let's do some planning and let's figure out how we can deploy this in the best possible way to benefit the ridership, especially those that rely on transit. So I agree with Milos. You can constrain it later, and the best thing to do is actually just to move forward and try it out. It actually doesn't cost that much money as much as people think. So.
Okay, so thank you, Jeremy, thank you, Milos. Again, if you have any follow-up questions, feel free to reply to the emails that invited you, or just to reach out to us directly. Again, thank you everybody for attending. Hope to host a few more of these to just talk about transit and specifically on-demand transit. I hope people have found this useful and interesting. If anybody has any topics that they want us to cover or they're curious to hear about, feel free to shoot me an email and let me know, because I'm always thinking of other things that we could be talking about to the transit industry. Again, everybody, just please have a good rest of your day and stay safe out there. Thank you for attending. Have a good day. All right. Thank you, everybody.